Welcome to The Explainer. Today, we're diving into a technology that's literally taking AI out of our screens and putting it into the physical world. For the very first time, we're giving robots a brain that can understand things a lot like we do. And trust me, this is going to change everything you thought you knew about what a robot can be.
So, for years, we've had these robots that are just incredibly strong, fast, and precise, right? You know the ones I'm talking about. In a factory, they can weld a car door with this perfect superhuman accuracy over and over again. But that's pretty much all they could do. Yeah, that precision was super brittle. I mean, there was this massive gap between their amazing physical skills and, well, their total lack of mental understanding. They were basically confined to cages, endlessly, mindlessly repeating a single task, with zero real awareness of the world around them.
But now we've all seen the crazy cognitive power of modern AI, right? I mean, think about ChatGPT. So you gotta ask, what happens when you combine that kind of brain with a physical body? Okay, let's really dive into this. Well, the answer is this revolutionary tech called a Vision Language Action Model, or for short, a VLA. It's basically a single system that can do three things. It can see the world, it can understand language, and it can physically act in that world. So it can look at a totally cluttered room, get a command like, hey, clean up that table, and then actually figure out how to do it. Now, what's really cool here, the real innovation, is this intermediate reasoning step. This is the game changer. The robot can now actually think before it acts, you know? It can look at a problem, break it down, weigh its options, and then form a plan, all before it even moves a muscle. Look, this ability didn't just pop up out of nowhere. It's really been an evolution. So first, we had LLMs, which totally mastered language. Then we got VLMs. Think about the image feature in ChatGPT that could see images. And now, VLAs are that final piece of the puzzle, adding the ability to take physical action.
All right, so let's see how this is all being built, because this has led to two really fascinating competing philosophies on how to actually build a robot brain. And this is perfectly illustrated by two of the leading systems out there right now. And this table just lays it out so well. You've got Google's Gemini, which uses this dual brain approach. So a massive AI in the cloud does all the high-level planning, and then it just shoots down simple commands to a smaller AI that's actually on the robot. But then you have Figure AI's Helix. It runs a single unified network completely on the robot itself. This prioritizes speed and, autonomy. The thinking happens deep inside the network, which makes its actions super fast and reflexive, kind of like our own muscle memory. But here's the thing. Building these models has revealed a pretty surprising truth. It's not just about having the biggest or smartest architecture. Nope. The real secret, the secret recipe, is the data. And Sergey Levine, who's a leading researcher in this field, he puts it perfectly. He says if you train a robot only on perfect, flawless demonstrations, that's a recipe for failure. Why? Because the real world is messy. A robot is never perfect. When it inevitably makes a mistake, it finds itself in a situation that it's just never seen in all that good data. So the crucial point here is that a successful robot needs a balanced diet of data. First, you pre-train it on this massive, diverse, and even low-quality data. That's what teaches the robot how to recover from mistakes. Then, you fine-tune it on a much smaller set of high-quality, expert demonstrations. That's how it learns to perform a task really, really well. Okay, so this new paradigm, this is unlocking automation in areas that were honestly previously impossible. We're talking about robots moving from the factory floor right into our daily lives. I mean, just look at this. We're seeing VLA-powered robots that can perform complex chores at home, sorting laundry, tidying rooms. They're bringing this whole new level of flexibility to logistics and manufacturing. And they're even entering really sensitive fields like healthcare. But, of course, the path forward isn't all smooth sailing. There are some significant challenges. These models can still make surprisingly simple reasoning errors. But beyond the tech, we have to proactively address the profound ethical questions. What about jobs, accountability, and what happens to our privacy? But fueling all this progress is this incredibly powerful flywheel effect. See, because these models can learn from any robot's data, every single machine that gets deployed in the world helps make every other machine smarter. This creates this just exponential acceleration in capability. It's wild. So this really brings us to the final takeaway.
General-purpose robots, they're not science fiction anymore. They are coming. So the question for all of us is no longer if, but how. How are we going to steer this incredible technology to create a future that is not just more automated, but also more equitable and beneficial for everyone?